Hello and welcome to XC Psychology. Today, we're going to try to answer the question, where does electricity come from? If you remember our last episode, we are made of matter, and matter is made of atom. Atom contains nucleus and electrons, and nucleus further contains protons and neutrons. You may also remember that we said protons have positive charges and electrons have negative charges. Understanding electrical charge is essential to understand how electricity is generated. Now, we can think of electrical charge as property, but not this kind of property. We take cats, for example. Most cats have paws. They have their pointy ears. They have very cute eyes. They have their whiskers. Some cats may not have hair, but most of them does. And they all have tails. And those are characteristics or the fundamental properties of a cat. Now, what does it mean for protons and electrons? It just means that, positive charge or, electrical charge is a fundamental property for electrons and protons. And protons have positive charge and electrons have negative charge. And different charges will interact differently with each other. Let's say we have Rob and Bob here. They look the same. And Rob is thinking, I don't like this guy. And Bob is thinking, I don't like this guy. They are too similar. And so they repel. So if both negative charges, they repel. Same goes for both positive charges. And let's say we have Harry and Body. And Harry is thinking, I wish I don't have much hair. And Body thinking, I wish I have some hair. And so one is, positive charge, one is negative charge, and so the opposite attract. So we remember with electrical charges, the like repel, the opposite attract. Now, with their interactions, we create something called the electric field. And we have another video in module 1, I think it's episode 2 in module 1, where we have a more formal understanding or formal explanation of electric field. But if you find that one quite challenging, maybe we can think of it like this. Say we have this cute penguins and this ice cream truck. When you're a kid, when you hear the sound of an ice cream truck, or when you see an ice cream truck in the distance even, you feel the immediate attraction to it. So you move, right? You move to what attracts to you, even though that attraction is invisible. And that is the key definition of electric field. It is the charges interaction, the push and pull between electron charges in the defined area that create the electric field. And say, I want an ice cream, this penguin also want an ice cream, so they repel each other. They're trying to get the last ice cream. And maybe same goes for, the ice cream truck. I don't want you to steal my business. I don't want you to steal my business either. So they repel each other. And this push and pull, even though you didn't see it, it is there. And that's how an electric field is created. And a fun fact to know is a proton is about 1,836 times more massive than an electron. So protons are like the parked ice cream truck. They're heavy, they cannot move. So electrons are like these cute penguins here. They're light. So most of the time, electrons does most of the moving. And the moving of charges creates electricity. So the key takeaways from today's episode, electric charge is a property. An electrical charge creates an electric field. Electric fields exert forces. Remember the push and pull, the repel and attract? Electrons are easier to move because they are lighter, much lighter. And electricity is the movement of electric charge. Coming up next. But what charged particles actually move inside living cells? Remember, we're building the foundation for neurobiology and neuroscience. And the answer is ions. So coming up next, episode 3, what turns an atom into an ion? I will see you there.